Good day, everyone. I go by the name Mensa Beyonce from the prestigious Wesley Grammar High, and I am here to introduce you to our very own STEM Rectus Club, consists of the robotics, renewable energy challenge, and STEM innovation. By the grace of the Almighty, we've been able to acquire a lot from each category. I would like to take you in a tour into our various groups and the goal we'd like to achieve. Ladies and gentlemen, buckle up your seats while we embark on this wonderful journey into the world of creative mind, productivity, and educational space. Now, let's delve into the world of celebrities and enjoy your CD. Thank you.
So good day, ladies and gentlemen. Today we are over here in Wesley Grammar Senior High Schools, and over here we have a young lady who is into piggery. So, young lady, can you tell us a little bit about yourself?
Please, my name is Amwa Princess Ayeyi, and then I'm the supervisor for our pig farm.
Wow, supervisor.
Yes.
So, pig farming, can you tell us how it is like, the troubles you go through and everything?
I think pig farming is something easier, but people think it's difficult because pigs are mainly claimed to be dirty, nasty, but pigs can be clean. They can be clean animals. Our pigs here are prolific breeders, which means they can produce at least 16 piglets at a time. And also they are exotic breeders, which we have the African dwarf and then the Landjoin. So I want to take you guys to the style so that we can explore more.
So, ladies and gentlemen, stay tuned.
Okay, so this building here is a semi-intensive system, which means our pigs are confined and then restricted indoor. We get to feed them properly and then take care of them. Also, we have the young piglets here and then the pigs. These ones are large black, and we have the large ones here.
System. And then the pigs, as you can see, they are fully grown at age 6, and about this age they weigh about 125 pounds. And then still, even though they are heavy, they can jump a 6-course wall and above.
What of you? How do you see this pig farm? How is it helping?
The pig farm is helping us really much.
Okay.
Because when you look at the benefits of the pig farm, it's a lot. They are manure you can use for fertilizers and others. So it's helping us a lot.
Good morning. We are here right now at Wesley Grammar Rabbit Habitat. I'm here with
Daniel Derek Dara as a STEM student.
Please tell us what we are here for.
Okay, since agriculture is the backbone of our country, we decided to start with rabbit rearing, which is also part of our STEM project in order to help increase agriculture in our country. So I can take you to the place where we rear rabbits, and my colleagues are also there so that we can tell you more about the rabbit rearing and how important it is to our country and how it can also help the school.
Okay.
So
let's go then.
This is one of the rabbits, and they they are herbivores which feed on plants like grasses. The herbivores which feed on plants like grasses. They are crafty and quick. After studying them for some time now, I found out that even if they are there, they can they can rotate their eye at 360 degrees in order to look at their back without even turning their eyes. And I also found out that when we bring them leaves, they're able to feed. They feed on them though, but they also feed on the feces, which means that there are some nourishments which are not in the leaves. So they feed on the feces in order to get some nourishment from the feces in their digestive system. Yeah, so there are a lot here. There are a lot of rabbits here. This rabbit has really helped us a lot. It has provided a sense of, it has helped us in companionship because they are really beloved. They are really beloved and they are also social. They are easy to interact with. So I would let him talk about the breeds and.
So about the breeds, we have the Fleming Giants. We have the California White here. This one is the Lion Gates, and it's with this one. So this and this are the lion head. This one is also a California White. Okay. This is a hybrid. This is a hybrid, and this is a California White with this one. This is the Fleming Giants. Okay, so for some importance of rabbits, they use them for research purposes, and then for also meat, and then as pets also. And then she's going to talk more about this.
And they are very sensitive and they dislike disturbance. And they are very cute to keep as pets.
So are there some diseases that affects them?
Yes, please.
So could you give some examples?
We have some fruit rots on the. It comes to the fruit of the rabbits, and if you don't take care, it can kill. Let's say kill the rabbits.
Is there a cure for that?
It looks so cruel. Yeah. Cruel. Yeah. That's massaging it with.
And then there's an ointment.
But this usually comes when the place is unclean. So wearing rabbits deals with like having a serene environment and a clean environment. About 80% of it is like you need it for a good health of the environment.
Okay, so thank you for taking us to your rabbit production unit. We'll move quick to the snail production unit. You're still here, and right now we are at the snail production unit. We are here with
Philip Watson.
Okay, so can you tell us something about your unit?
So this is the snail's habitat. As you can see here, I've opened it throughout so that the sun can sterilize it completely. So here is a small something that here's the biscuit lab, and here I'll take this as a small habitat of the snails. So as they reproduce, I'll shift them from inside here to their scallop.
Okay, so what do you feed the snails?
Yeah, I can feed them with kitchen leftovers and bread, and even the best thing for them is leaves.
Okay, thank you. And what about some health benefits of rearing the snails?
Okay, the snails produce blue substance. That is also medicinal.
Do you know prominent people who are into snail farming?
Okay, I know Kofi Edu, popularly known as Ejako. That is into snail, and it also helps him with money.
So how expensive is the unit?
These are the small ones here, and each of them is 8 cedi. And if you go to the market, you get the big ones for 50 cedi.
So this unit is very lucrative.
Yes, please.
Okay, thank you, Philip.
We have Wesley Grammar's very own smart aquaponics system. An aquaponics system is a method of cultivating crops with the help of a
It's a combination of aquaculture and a hydroponic system in a symbiotic environment. A symbiotic environment is an environment where the plants and its natural features are working in harmony. So over here we have catfishes, and then we have our vegetable unit production. I'll hand over to my friend here to elaborate more on the prototype.
Our prototype is in two ways. That is the plant cultivation and then the fish rearing. Over here we have catfishes in our fishing unit, in which they produce their feces mixed with the water and is then pumped by a 9-volt submersible aquarium pump through a transparent tube into the uppermost PVC pipe. Then water from the uppermost PVC pipe then goes into the second uppermost PVC pipe with the help or the method of an Iruka can. The same process enters into the valve here. Now we have here where our crops are growing with only water and here soil. One may ask, an aquaponics system, what is soil doing inside it? Now, looking at how Ghana is right now, we are trying to improve on the method at which they farm, that is geoponic system. So what we have here is not just a normal soil, but it is cocoa peat mixed with organic manure in order to boost their growth rate by 50%. We have here our filter, in which it filters the water from the uppermost PVC pipe and goes down into the fishing unit producing oxygen. As you can see right here, this is our filter. And then our filter has a 3-meter square mesh, gravels, sand, and cotton. We have our light here, which produces ultraviolet B. Ultraviolet B helps to improve the growth rate and also helps in diseases, which means that it is helping to protect our crops against diseases and also help to boost their flavor and texture. One may ask, what is a cocoyam tree or a cocoyam plant doing here? Our system also helps in pre-sprouting. So we are also pre-sprouting it. And if you want to use our system to grow cocoyam, that means you're only growing it for the leaves. But if you want to grow it for the cocoyam, that means you have to transplant it.
Looking at our system, as you said, we have a light bulb here that produces ultraviolet B rays. They help in the nourishment of the plant and also helps the plant's defense against pests and diseases. We have this lever here which we pull up to adjust the length at which the crops grow, because these can grow up to some certain limit when the lever is down. So the lever helps it move up so that they can get more space to sprout. We also have our system being powered by solar, which means we use solar energy, and the energy stored from the sun is found in an accumulator. We also have our IoT user-friendly mechanism here, which helps control the whole system as a whole. This is the SAS. Thank you.
Gentlemen, someone might stand somewhere and say, so you did this, is that it? No, we the students of Wesley Grammar came together and decided to enlarge this prototype you see here. So ladies and gentlemen, welcome to the EXP Oasis. That's the expansion project of the smart aquaponic system. Over here we have our fish production unit. That's over here. We have catfishes. This poly tank can contain up to 2,000 fingerlings, weighing 0.5 kilogram each. And once they mature, this poly tank can contain 1,000 catfishes. Over here too, we also have more catfishes over here. This drum currently contains 500 catfishes inside it. And then its feed, also we give it 2 disposable cups each day. 1 disposable cup for the morning and then for the evenings.
So we have here our fishing unit. One may ask, what are these green things doing on our fish pond? This is called azola, also known as duckweed. One may ask, what is it doing or what function does it play? Now, the azola purifies the water. It helps in aeration. It is also used to feed our catfishes. The azola also help in or reduces evapotranspiration. And 1 kilo of azola is costing 50 cedis in the Ghanaian economy. Thank you.
Can support plants like tomatoes, peppers, spinach, and many more. So looking at them, we produce them on high rates, which helps the farmer get more money. So this is a summary of our extension. Here we have a farm that we use to nurse the seeds in order to help in the transplanting. We have plants like the carrots, garden egg. Let's keep going.
Okay, good day, ladies and gentlemen. I'm the name of Jotebi Ado, and here is a Farm for STEM Innovation Club. So here we have our okra. It's now germinating, as you can see here, and here too we have our carrot being planted in lane, as you can see, and these are being irrigated by the fish, the water, the byproduct from the fish. So we are using that to water because of the nitrogen inside the water. It helps the plants to grow and has the quality nutrient. So I'll hand up to my colleague to explain more about our farm.
Okay, we also have maize and we have cucumber here. Please follow me. So this is the cucumber plant. It's now growing. We will make a wooden something to connect the cucumbers to it so that it grows in a straight line.
Good day, ladies and gentlemen. I'm live in Wesley Grammar School. Looking right here, I can see a beautiful piece of artwork. I want to know more about it. Gentlemen, please tell me your name and what this is.
Okay, I respond to the name Adusulum Etonom. This right here is our water purification system.
So please, and your name?
Agnes Afagoma.
Okay. So how does this system work?
Okay. So this system right here, as I said, is already a water purification system. Water is being poured up here. As you can see, dirty water is being poured up there.
Okay.
Water.
Okay.
It then flows through. This right here is our dirty water reservoir.
Okay.
It flows through in here, then comes down here.
Okay.
Okay. This right here is our filtration system, our filters.
Okay.
So since we wanted the amount of water to be a lot, we decided to use 3.
Okay.
So the more amount of water you want to filter, the more filters you place in your system.
Okay.
So since we wanted that to happen, we pour this. This contains gravels, fine sand, activated charcoal, cotton, and a 3mm square mesh.
Okay.
This filter also right here contains only cotton,
Okay.
which then traps dust particles and germs. Okay. This right here is where the filtered water comes. Okay. So as you can see, let's demonstrate and see how clean the water is.
Wow. Wow. Ladies and gentlemen, we all saw how she poured the dirty water into it. And looking at the time he used, illustrating how it all works, coming down to the final point, we saw what? A clean water. This is a beautiful piece of artwork. I want to say, Wesley Grammar, thank you very much and keep it up. Thank you.
Hello, please, what's your name?
Please, I'm in the person of Tito Giftifari with my colleagues.
Asari Jerry Dakwa.
Amigash Clementia.
So what do you have for us today?
Please, we are here to present to you the Imashi Convenient Bioreactor. And it's going to produce gas from the household. You can produce gas locally. Yes.
Okay. So how does it work?
Okay, this works on the principle that if you put fecal matter in this our bucket, it's going to produce methane gas. And that methane gas is what is going to be collected. That methane gas is what is going to be collected and accumulated and then pass through a different process to produce our biogas.
So you mix your organic waste with water, then you pour it in here. After it decomposes, the air comes here. So we are going to keep in silica gel and aluminum sponge here, which will purify it. Then the gas will pass through this tube. It will be here. It will be stored in here and compressed. So this tube is also connected to the Bunsen burner where you light up your gas.
Okay, so this process works on an anaerobic digestion and an anaerobic system. So therefore, there's not supposed to be any gas inlets from anywhere. So there's not supposed to be a leak of any gas. So the gas also produced from our project is also very environmentally friendly, which means when it gets into the atmosphere, it does not pollute the atmosphere. It does not lead to any form of pollution in the atmosphere.
Okay, so this is the robotics aspect of STEM. And then here, what we are doing here was actually sponsored by FIRST. That is for inspiration, recognition of science and technology. Okay, so here's the masterpiece. This was the artwork for 2023-2024. And these are some of the components you find here. So now basically what we do here is we actually code robots so that they perform certain missions here. So I'll leave it to my team members to do that for us to see. How they figure out here's a component for the rolling camera. So the robot is actually supposed to do this to actually move the camera. And then here's the light show. So you can see that everything here is about art. And we performed that's earlier this year at Legon, and then we came out fourth. That's for our robotics team, West Robotics. Yes. It's really an amazing program because it teaches young minds how to code and do a whole lot of stuff, and it introduces them to the world of tech.
A challenge was thrown on senior high schools on the theme, use application of renewable energy technologies in solving land degradation and water pollution. So we came up with a solar-powered eco-friendly toilet facility, and here is how it works.
So talking about the functions of this system separates our urine from our feces for composting. So as you can see, we have the urine diverter, and this one helps us to separate the urine. This gallon here too is used to collect rainwater from the back. Please come. So this one is the rain gutter. So when it rains, this rain gutter harvests rain, and that harvested rain falls into the reservoir that we saw inside the yellow gallon, and that one is used for washing of hand over there. We also have our electrical place because the challenge was about renewable energy. Our project uses solar energy to work. So as you can see here, this is the power inverter, which transforms the DC into AC for the system to work. We have a fan blowing unit also in our system that uses electricity to blow sawdust onto the feces. That's it. So you pour the sawdust in here, and you just press on the flash button. As you press on the flash button, the sawdust will be blown from this side into a barrel under it where the feces will be. So when the sawdust enters the barrel, it covers the feces, and as time moves on, it helps the feces to change into compost. So this system is a system where we use human feces to create compost for agricultural purposes.
So in a nutshell, what you see here aims to conserve water resource from pollution and also to minimize waste within our metropolis. And not only that, it also creates job opportunities for people like
the masons, carpenters, plumbers, and also it solves 12 out of the 17 SDG goals. Thank you.
Good day, ladies and gentlemen. I go by the name Echampon Kofi, and this is the renewable energy section of the STEM Innovation. This is an incubator. One may ask, what's an incubation of egg? Incubation of egg is the process whereby fertilized eggs are being placed inside for optimum temperature, humidity, and ventilation. The eggs are being placed inside for 21 days until it will be hatched. And I and my team came up with this system. And this system, it's being automated. So every 2 hours, it will turn. So let me take you through it. This is how it works. This one over here tells us the temperature of the incubator. So when we open it, yes, these are the layers, these are the shelves where we put the eggs. So it takes about 264 eggs. And we used bulb as a source of heat. We have 2 fans over there which regulate heat throughout all the eggs. So every 2 hours it will turn. So when it turns, that means that the embryo will be balanced through the shells of the eggs so that it won't spoil. When the temperature decreases below 36, it will get spoiled. So our machine is being set so 36 to 38 degrees Celsius. And we also have this one here, which is the bowl which water is being placed inside as a source of humidity. So this is our incubator. Thank you very much.